Here's another question. What is constant for a battery, voltage, current, or both? Okay, last call. Now, you see that we have two main groups there, and one of those groups is getting it, and one of those groups is still confused. Okay? Now, when we go and buy a battery, on the battery it says, I'm a 12-volt battery, or I'm a 6-volt battery, or I'm a 1.5-volt battery. It never says, I'm always going to give you 5 amps. No, it brags about its voltage. And a battery, if it's ideal, will always, always, always have that exact same voltage that it brags about from its negative terminal to its positive terminal. Now, the most ideal batteries that we have in real life are rechargeable batteries, NiCad batteries. And a NiCad battery, if it says it's 1.5 volt, by golly, come heck or high water, no matter what you hook to it, it's 1.5 volts. An alkaline battery, it says it's 1.5 volts, and it'll try to be 1.5 volts. But if you start getting a lot of current going through it, it'll just curl up and die. And it's not the physics that's failing, it's the chemistry inside. It's always the chemistry that fails, never the physics. Okay? Now, if I take a 6-volt battery and I hook it to 2 ohms of resistance, that's fairly easy to get through. By V equals IR, that's going to give me 3 amps going around that circuit. If I take that same 6-volt battery and hook it to a resistance that is 6 times bigger, I get a current that is 6 times smaller. What goes around that circuit depends on what's in the circuit. Now, you know this is true. You see this in everyday life. If you go out to your car battery and you grab both terminals with your hands, just grab the positive and the negative with your hands, what happens? Nothing. You've got enough resistance in your body that there's not going to be hardly a trickle that's going to go through your heart. You'll be fine. Have any of you ever dropped a wrench across the terminals? Only once, right? You never do that a second time. If you accidentally drop a wrench across the terminals, that wrench has so small a resistance that you get a huge flow. A flow big enough that potentially it could spot weld that wrench to the terminals. Then you're really in trouble. Then you're going to have a mess. Now, that battery can either give nothing or it can give a gusher, depending on what you connect to it. And that's the idea that you need to keep in mind when you get to that tutorial, is that it depends on what the circuit has for resistance. The more resistance we have in the circuit, the smaller the current through the battery. Okay? Now, that's a good stopping point. We'll pick up on Monday. Have a good weekend, people.